Should be no problem. Number 20. 20 and 23, you're just expressing the expression or each number in scientific notation. So you should get 1.22 times 10 to the 6th. Everybody get that?
That's
20.
What?
1.22 times 10 to the 6th.
I thought it was a 7.
Should be the 6th. Alright. 23. 1.3 times 10 to the negative 6. How do we know whether to keep the exponent positive or negative?
If it goes right.
Well, if it moves right. But if you're, the easy way to know, if you're going from standard to scientific, if your number starts out large, right? And then it starts out large, and then we're going to be positive. It starts out small, we're going to be negative. Okay. 26. 1 times 10 to the 8th. 31. We're expressing each number in standard form.
I have a question.
Yes, sir.
How's 26 10 to the 8?
Was 100 million.
What?
100 million.
It can't be 100.
It says 100 and then million behind it.
Okay.
So 31.0005. Right? 32 should be 873 billion. All right. Flip over on 36. We are multiplying. We're evaluating the product of the quotient. And then you're expressing it in scientific and standard form. Alright? Okay. So 36, you should get 1.9035 times 10 to the 6th, and then 1,903,500. 40. 8.55 times 10 to the negative 8. You should get 0. There should be 7 zeros and then 855. Question?
It was right. Where it was.
He helped me.
I had like 100.
You have what?
27 zeros.
Wow, 27.
You taught me wrong.
I'm sorry.
When you add, all right, look, when you add right there, you've got 10 to the negative 18 times 10 to the 9. When you multiply with the same base, add the exponents. What's negative 18 plus 9? They're opposite signs, so you subtract.
Oh, well,
Keep the
my
sign
calculator
large.
gave me a wrong answer.
All right. 44. 9.288 times 10 to the 8th, or 928,800,000. All right, 48. 5.29 times 10 to the negative 6, or you should get 0.5 zeros and then 529. And then 52. 4.3 times 10 to the 10th, or 43 billion.
All right.
Any questions on scientific notation?
That's kind of one of the easiest things to learn.
I agree. I'm not listening.
I got it wrong though.
It'd be easy. You got to test like
This is what we're doing it now, right now.
Any questions on that? Are we good? All right. Flip to page 421. We're going to go over these. This is everything that's going to be on the test. Okay? Everything that we're going to do on the test, or the questions that will be on the test, we're about to put on the board. All right. Number 1, we've got x cubed times 4x to the 5th. Well, what's your coefficients? Coefficients. Your exponents are 3 and 5. 4 and what? Your coefficients are 4 and 1. All right. Same base. Add your exponents. Well, 4 times 1 is 4. X stays X, and then 3 plus 5 is 8. That is number 1. That's when you add exponents, or when you're multiplying exponents, all you have to do is add the exponents together. Okay? The second one, when you have a power raised to a power, distribute your exponents. M is squared. 2 times 3 is going to give you m to the 6th. P to the 5th. 5 times 3 is going to give you p to the 15th. When you have powers raised to a power, multiply the exponents. No, sir. Does that make sense? Are we good on 1 and 2? That's the multiplication property. That is when you have a power raised to a power. If you're multiplying, add exponents. If you're raising a power to a power, multiply. All right, look at 7. We're dividing. What are your coefficients?
7.
That is 7.
Problems.
What are your coefficients?
X and Y.
Coefficients. 2 and 6. So 2 divided by 6, we got X. What we do, what's the division property? You're dividing variables with exponents. What do you do with exponents? You subtract them. That's to the first power, that's to the first power. 1 minus 1. And then y to the 0 goes to 1, because anything to the 0 power is 1. You agree with that? Alright. 2 divided by 6 is 1/3. X goes to the 1 minus 1 is 0. So that becomes 0. What's anything to the 0 power? 1. Your answer is 1/3. Because 1/3 times 1, and then times another 1, it's going to still give you 1/3. Alright? 8. Here's the deal. You've got M, N, and P. Your M's, the numerator exponent is 7, the denominator exponent is 3. Your N, numerator exponent is 4, denominator exponent is 3. Your P, numerator exponent is 1, denominator is 1. 7 minus 3. 4. 4. 4 minus 3. 1 minus 1. Anything to the 0 power gives you 1. So you have m to the 4th n. Well, that p goes to 0. That's p to the 0 power. Anything to the 0 goes to 1. So it's like you're just multiplying it all 1. Questions on 7 or 8?
What is that in the 36 beside 26? No, it's on 7.
X to the 1 minus 1.
What is that? Where it says X times 7?
It was 1 minus 1, it becomes 8.
Write them down.
Question: how many of you are in a math class besides this one? Everybody?
Oh, wait, besides this one in the day?
Yes.
No,
Oh,
this
no,
really
you're
doesn't
right.
count.
Yes,
I'll probably do that next year though to get caught up with everybody else.
I'm math teacher.
Why are you like
I was just curious.
You're taking it.
We have to.
Should have raised your hand.
Well, you got it. You ready to roll?
Almost.
What's your favorite thing? Because what's your favorite thing?
I like
Man,
that.
I'm very neat thing, that's what I'm good at.
It's in everything.
You are correct, sir.
I used to argue on that. And then one day he was like, "How you want me to
There. All right. Number 11. We have two problems in number 11. What we're doing, we're taking, this is an exponential form. We're going to take that and put it in radical form. Okay. Now, if we know it's raised to the 1/2, that means we're doing what with it? We're square rooting. Okay. Now, that numerator, your numerator tells you what you're doing to the base. Are you taking the base to an exponent? Well, yes, technically we are, because it's just to the first power. Right? The denominator tells us what root we're taking. Well, if it's 2, we know we're taking the square root of 42. We don't have to put a 2 there. It's understood that the root we're taking is 2.
If we put it to there,
If you put a 2. All right, now, if you have 42 to the 1/3, 42 is still raised to the same power. It's still raised to the first power. But what root are you taking now? The third root.
Square.
So the cube root of 42. That would be what's different. All right? Do what? Which part? This one? All right. The numerator is what we're raising this to. What are we raising this power? What power are we taking this 42 to? Well, no, there's nothing there, right? If there's nothing there, it's assumed it's a 1, right? So it's 42 to the first power, and then we're taking the cube root of that. This denominator is the root.
why would you take the cube root?
Because it's to the 1/3. There's two. We made this one up. That's not in number 11. But somebody asked us a question first period, so I just left it up. Number 11 just says to the 1/2. All right, 14. 14, we're taking it from a radical form and we're making it in exponential form. All right, what root are we taking? The second one. What are we raising 55 to? The first power.
Could be 1/2 or
So
1.
it's 55
Square root.
to the 1/2.
I'll write, yeah.
All right. We're doing the same thing with this one. 5 square root of k. Are we doing anything to 5?
No.
No, it says 5. What are we doing to k? We're taking the square root. We're raising it to the first power, taking the second root of it. So it's 5 times k to the 1/2. All right? That's all we're doing. All right, 17, we're going to actually evaluate this. We're taking the cube root of 729. We need 3 numbers that are multiplied together that give us 729. Okay? How do you know? What do we know about 729? I know that 9 goes into 72 and 9. Correct?
Right.
9 goes into 72 how many times? 9 goes into 9 how many times?
It's 9.
So we got 81
divided
divided by 9.
It is 9.
Alright, what do we know about 81 now? It's 9 squared. 9 times 9. How many 9s do we have?
3.
3. How many 9s do we need? 3. So what's the cube root of 729?
3.
No. Alright. Questions on 17? None? Through 17, are we good? What is 729 divided by 9? 81. Alright. 72. Number 19.
the cube root, or 1,331 to the 1/3 power. Basically, we're taking the cube root of 1,331. Now, with this one, how do you know what's the first thing I can try to divide 1,331 by? I do realize everybody realizes we have to have 3 numbers, correct? If we take 10, multiply it by itself 3 times, we get 1,000. So we know it's going to be more than 10, correct? Divided by 11. What do you get?
No, I don't want to answer that.
Divided by 11.
121.
That's 121.
Just 8.
What do you know about 121?
11 times
11 squared.
11.
How many 11s do you have? How many you need? 3.
Pick it up.
All right. Any questions on 17 or 19?
No, that's easy.
Evaluate.
We all better make 100 on this. There's talking back there.
Number 21. Hey, I'm going to let y'all get done. We'll go over this one, y'all get done. Everybody understand? I don't lose my temper often. I don't lose it too much anymore. However, if I'm going to spend my time up here trying to go over this for you, otherwise we just take the test on review days. There won't be a review. If everybody knows what's going on, there won't be a review day. We understand? You'll just take the test on review day. And there won't be any retakes. If we don't need to pay attention, we won't retake the test. We won't have a review day. I'll teach it to you, you'll do the homework, and we'll move on. We'll do 2 lessons a day, if that's the case. If everybody knows what's going on, let's just do 2 lessons a day. So you've got 2 options. 1, shut your mouth when I'm talking. Or 2, this class is going to get exponentially harder than it is right now. Does that make sense? Okay. Number 21. 8 to the 2/3. What changes? What changes from this to this? One part. The numerator. The numerator changes. What root are we taking? The cube root. The denominator still, that's still the root that we take. We've got the cube root of 8. What does this change? That becomes what we take the answer to. That becomes the exponent for the answer. Alright? What's the cube root of 8? 2. What do we do to it? Square it. What's 2 squared? 4. Questions on 21? The only thing that changes is the numerator. The numerator is, once you find the cube root, then you raise it to the exponent that the numerator has. In these, it's all been 1. Same thing up there. The numerator was 1. So once we found 11, we take it to the first power, which is still 11. Alright? 25. 25, we're solving for x, but it's an exponential equation. X is in our exponent. This makes it an exponential equation. What do we know about exponential equations? Well, we know that if we get it to where we have the same base, we can drop the base, set the exponents equal to each other. So I want to make 4,096 4 to some power. Okay? Well, if I know it's got to be 4 to some power, let's divide 4,096 by 4. What do we get?
1024.
1,024. Well, take that 1,024 divided by 4. What do you get?
256.
256.
Coach, you put a 6.
I'm sorry. Divide 256 by 4. What do you get?
64.
64. 64 by 4 is going to give you 16. And 16 is going to be 4. How many 4s do you have? 1, 2, 3, 4, 5, 6. So 4,096 is 4 to what power? The 6th. You have 4 to the x, equals 4 to the 6th. Are your bases the same? Yes. Set your exponents equal to each other. X equals 6. $25. Does that make sense? Any questions so far through 25? All right. 32. We're going to take this in standard form.
Is that 41?
4.0.
You just gave us that.
Alright, I'm going to take this. That's in scientific notation. I'm going to make it standard. We're going from scientific notation to standard form. That's 4.1 times 10 to the negative 3. That means we're doing what?
Moving the decimal to the left.
Moving the decimal to the left 3. We're going to take it to 1, 2, 3, 0, 0. So our answer is 0.0041. Alright? Not here. We did multiply by 10 basically already. Moving the decimal. Alright, 36 and 38. We're finding the product and the quotient. Alright, we're going to find it in scientific notation and standard form. So, in 36, what do we do first?
Take your real numbers and times it.
Multiply your whole numbers. Or multiply the real numbers. We've got 2.13 and 3. What we multiply, we get what? 6.39. 6.39. We've got times 10. Are we multiplying?
So yeah.
We add the exponents to the 7. So we have 6.39. Move the decimal which way? Right, 7 because the exponent is positive. Add your zeros. We have 63,900,000. Questions on 36? Does that make sense? All right. We did the same thing on 38. The only difference is now we're dividing.
Instead of add your
Divide your real numbers. What do you get? 3. 7.5 divided by 2.5 is 3. We have 10 to the 8 divided by 10 to the 4. The division property of exponents tells us we subtract. So we have 3 times 10 to the 4th. Where's the decimal at in the whole number? Divide. It's to the right of your whole number. So you have 3.0. Move to the right 4. So our answer, 30,000. Alright? That is everything that's going to be on the test. That's it. I mean, that's everything that's going to be on the test. Alright? This will probably be the easiest. This may be easier than the first test. This test probably will be easier than the first test. Alright, here is the review. Now look, you're going to turn this review in for a homework grade. This review is a 100-point homework grade. Alright? On page 421. Open up to 421 so you know what to do. I don't care if you have to circle it in your book, do whatever you have to do. 3 through 6. 9, 12, 13, 16, 18, 20, 22, 26, 29, 33, 37, and 39. It's right there on the board too. Alright? That is the homework. That's the review. If you can do the review, you can do the test. We will turn the review in as soon as you walk in the door tomorrow, or as soon as you walk in the door Thursday, and then we will take the test. All right? Yes, sir.
We don't do 3 through 6.
Yeah, 3 through 6.